Hello everyone, and welcome to this video on integration using trigonometric substitution and half-angle identities. So let's start off with trigonometric substitution. So when you use trigonometric substitution, that's when you see the integral of something that contains one of the following: the square root of a squared minus x squared, the square root of a squared plus x squared, or the square root of x squared minus a squared. And keep in mind that a is just a constant. So for example, it could be 3, it could be 4, it could be just a number. So what you do is you substitute x equal to something. So for this first case, you substitute x equal to a sine of theta. For this case, you substitute x equal to a tangent of theta. And for this last case, you substitute x equal to a secant of theta, where secant of theta is just the same thing as 1 over cosine of theta. And remember these two identities, you're going to need to use them. So the first one's the Pythagorean identity. And if you divide both sides by cosine squared of theta, you can get this identity. 1 plus tangent squared of theta is equal to secant squared of theta. So if you want, then go ahead and pause the video here and try to remember all of this. All right, but let's get into an example problem. So the integral of the square root of 16 minus x squared dx. So that's of the form the square root of a squared minus x squared dx, where a is equal to 4. So we substitute x is equal to 4 sine of theta. And after that, we differentiate both sides of the equation with respect to theta. So the left side just becomes dx over d theta. And on the right side, well, you know that the derivative of 4 sine of x is 4 cosine of x. So therefore, the derivative of 4 sine of theta with respect to theta is just 4 cosine of theta. All right, and then isolate dx. So multiply both sides by d theta. And then plug in the values you determine. So x, we substitute 4 sine of theta for that. And dx, we substitute 4 cosine of theta d theta. All right, and then now we simplify. So we can carry out this constant right over here out of the integral. And the quantity 4 sine of theta squared is just 16 sine squared of theta. And we can carry the 16 out of this radical. And then we can just move that out of the integral as well. And 1 minus sine squared of theta, that's just cosine squared of theta from the Pythagorean identity. And then after simplifying, we get 16 times the integral of cosine squared of theta d theta. So to solve for this integral, we use the the double angle identities. So from that, you can get that cosine squared of theta is equal to cosine 2 theta over 2 plus 1/2. So you plug that in, and then solving for this integral right over here by first taking the integral of each term and carrying out constants, and then using u substitution for this, you can get that this integral is equal to 1/2 times 1/4 times sine of 2 theta plus 1/2 theta. And then now there's a 16 out in front, so you can distribute that. And then it simplifies to 4 sine of 2 theta plus 8 theta. All right, but now you need to change the thetas to x's. So we set x equal to 4 sine of theta. So that means that arc sine of x over 4 is equal to theta. So now we plug that in. All right, and notice that we have sine of 2 times something. So we can use the double angle identity for sine to simplify this. So that this becomes 2 sine of the angle, which is arc sine of x over 4 times cosine of the angle. And to simplify further, well, sine of arc sine, they just cancel each other out. And cosine of arc sine of x over 4, to simplify that, you draw a right triangle where the opposite side is x over 4 and the hypotenuse is 1. So you know that this angle right over here needs to be arc sine of x over 4. And then cosine of this angle, you can see that it's adjacent over hypotenuse, And the adjacent, we can determine that with the Pythagorean theorem. All right, and then so we get that cosine of arcsine of x over 4 is the square root of 1 minus x squared over 16. And then simplifying this further by canceling out 4 and 4, we get that this is our final answer. So this was a long process, but the most important thing to remember is the substitution. So what you should substitute x equal to. All right, so now here's a practice problem. If you want, go ahead and pause the video and give this a try. And if you need, you can go back in this video to see like what you need to substitute x equal to. But anyway, here is the solution for this problem. All right, so we have the square root of x squared minus a squared, where a is equal to 1. So in this case, we substitute x equal to 1 times secant of theta and differentiate both sides of the equation. So and make sure you differentiate with respect to theta. The left side becomes dx over d theta. The right side, so secant of theta is the same as 1 over cosine of theta. And if you use the quotient rule, you can determine that the derivative is secant of theta times tangent of theta, and multiply both sides by d theta. So now plugging in the values. So first plugging in x equals secant of theta, and dx is equal to secant theta times tangent theta dx. All right, and then now simplifying. So secant of theta in the numerator and denominator cancel out, and secant squared of theta minus 1, that's just tangent squared of theta. And then simplifying further, we get the integral of tangent squared of theta d theta. And I've already told you what this integral right over here is from the hint. It's equal to tangent theta minus theta. And the reason why this is because you can think of tangent squared of theta as secant squared theta minus 1, and the integral of secant squared theta d theta is tangent of theta, because the derivative of tangent theta with respect to theta is secant squared of theta. All right, so now we need to change all of the thetas to x's. So x equals secant of theta. So arc secant of x is equal to theta. So we plug that in. And to simplify this, well, we draw a right triangle where the hypotenuse is x and the adjacent side is 1. So this angle right over here is arc secant of x. And tangent of this angle right over here, it's opposite over adjacent, which is square root of x squared minus 1. All right, and then this theta right over here just becomes arc secant of x. And our final answer is the square root of x squared minus 1 minus arc secant of x plus c. So here is another practice problem. And here's a solution. So we see the square root of x squared plus a squared, where a is equal to 1. So we substitute x equal to 1 times tangent theta and differentiate both sides with respect to theta. The left side becomes dx over d theta, and the right side becomes secant squared of theta. Multiply both sides by d theta and substitute. So x is equal to tangent of theta, and dx is equal to secant squared theta d theta. And so tangent squared of theta plus 1, that's secant squared of theta. And then after simplifying, we get the integral of secant theta d theta. And that's equal to ln of the absolute value of tangent theta plus secant theta. And the proof for that is actually a little complicated, but you can search it up if you're curious. So now we change the thetas to x's. So x equals tangent of theta. Our tangent of x is equal to theta. So this tangent of x, we know that's just equal to tangent of theta. We know this is equal to x. And secant of theta, so we change that to arctangent of x. And we draw a triangle. So the opposite side is x and the adjacent side is 1. And this angle, secant of this angle is hypotenuse over adjacent. That's just the square root of x squared plus 1. All right, and now our final answer is ln of the absolute value of x plus the square root of x squared plus 1 plus c. So now we're getting into trigonometric identities. Here's a list of them, and I don't recommend you to remember all of them. And if you're coming from my series AP Calculus, AB, and 12 short videos, then we've already seen a lot of these, either directly or indirectly. And the only ones that we haven't covered yet are sine of a over 2, cosine a over 2, and tangent of a over 2, which are the half angle identities. And that's what we're going to learn right now. So you just saw what sine, cosine, and tangent of a over 2 are equal to, but I want you to understand why that is the case. So from the double angle identities, you know that 2 sine squared of x is equal to 1 minus cosine of 2x. So now what is 1 minus cosine of x? If you want, go ahead and pause the video here and think about this. So here's the solution. Instead of thinking of this identity right over here in terms of x, we think of it as 1 minus cosine of 2u is equal to 2 sine squared of u. And now we can substitute x equal to 2u. So then we get that 1 minus cosine of x is equal to 2 sine squared of x over 2. And this is where the half angle identities come from. So if you divide both sides by 2 and take the square root, you'll get plus or minus the square root of 1 minus cosine x over 2. And that's the half angle identity for sine. But you don't need to know that for this next problem. So just use this identity for this problem. So if you want to try this problem, then pause the video here and think about it. Okay, so here's the solution. So first you use u substitution, set u equal to pi x, and du over dx is equal to pi. So now isolate dx. All right, and plugging in the values, pi x is equal to u, dx is equal to du over pi. We carry the constant out, so 1 over pi, we carry that out. And from the identity that we just saw, 1 minus cosine u is equal to 2 sine squared of u over 2. All right, and then now the sine squared and the square root cancel each other out. And then the square root of 2, we can just move that constant out of the integral. So we're left with this, the integral of sine of u over 2 du. And using u substitution, if you set v equal to u over 2, you can get that this is equal to 2 times cosine of u over 2. All right, and then now undoing the substitution, so u is equal to pi x, and then we get that this is our final answer, negative 2 square root of 2 over pi cosine pi x over 2 plus c. And that's the end of this video. So if you're coming from my series AP Calculus, AB, and 12 short videos, then I'll see you in video 10.